So we're going to talk about Bernoulli's principle and how Bernoulli's principle affects or is the guiding principle that allows Venturi's, the tool, or a Venturi effect to work. And that leads us to ejectors, which is really just the end state, more or less most common tool that this is functional for. I say that knowing that that's not actually true. We use ejector type tools or Venturi based tools for other things as well. So we'll get into that. So Bernoulli's principle is a physics thing, and it's pertinent to liquids or gases that can move around like liquids. States that an increase in speed of a fluid, like a liquid or a gas that moves like a liquid, occurs simultaneously with a decrease in static pressure or a decrease in fluid's potential energy. All right, the part of that that's more pertinent to us is that an increase in velocity of a liquid or gas will result in a low pressure area surrounding the flowing liquid or gas. Where it speeds up, where it increases in velocity, you will get a decrease in pressure. And alternate definition, an increase in velocity occurs simultaneously with a decrease in pressure. Usually, I mean, there's some other pieces to that can kind of throw it off, but in the water world and water handling world, that's pertinent to firefighting, that's fairly accurate. So this is just another way to describe it, a little more technical, a little more scientific, I suppose, physicsy. Take this as you will, read through that and research on your own to know what you want to know. We'll boil it down to the basics here by the end of this discussion. Outcomes of Bernoulli's principle. What does Bernoulli's principle produce that I use in my everyday life or in my firefighting life? Aircraft wings and how lift is generated is tied to Bernoulli's principle. Venturis, the effect of a Venturi, the Venturi effect, and the tools related to which are also commonly used in fire apparatus. So a Venturi is a thing or an effect, but it is a system for speeding the flow of fluid by constructing in a cone-shaped tube, like your ejector, which is the output of this. But a Venturi is an effect, it's also a thing, and it creates that vacuum that we use inside of an ejector. So Venturis take Bernoulli's principle and put it into practice. Bernoulli's principle is just the principle that describes it. The Venturi is the tool or the effect that creates it. So here we go. The Venturi effect is the reduction in fluid pressure that results when a fluid flows through a constricted section. As we were kind of describing, that constricted section can also be referred to as a Venturi, an item or thing, but it's really the fact that it creates this effect of Venturi that causes that low pressure. And here is the diagram of a Venturi. So when your pipe's big, as it enters this pipe, it's larger, it gets constrained down, necked down to a smaller area, therefore the velocity has to increase, but when the velocity increases, the pressure decreases. And then once it comes out the other end of that, the velocity decreases in the larger pipe and the pressure increases back to where it was, assuming everything's flowing in, standard function. So some application pieces of how these are used in everyday life, or probably not really everyday life, since we're talking about ships doing underway replenishment isn't every day for everyone. However, these are some functional exposures to Venturi's and Bernoulli's principle that affect things around us. And more of those. These all came out of some list I found. Anyway, things that are more applicable to us, injectors, also called ejectors, are used to add chlorine gas to water treatment chlorinating systems. Well, yeah, it's the same concept as an ejector that we use to grab more water and shove it into a hose. Foam proportioners are another pretty common Venturi application, Venturi effect application that we use in fire apparatus. And there's your definition of an ejector. Water ejectors are vacuum pumps driven by high pressure water or similar medium or steam. They use kinetic energy to drive a medium of the driving medium to suck in gaseous vapors, other liquids, and then discharge the resultant mixture against a counter pressure. So this is how an ejector that we used for ejecting water back into our tank would work. I constrict that flow, reduces that pressure, creates a suction because of that Venturi effect. More on ejectors in the ejector video with actual pictures of them, and that would probably be more helpful. As far as ejectors go, the key things to remember here, or the piece you really need to know or recognize, is the piece you need to know for class. Bernoulli's principle is the principle that allows us to, or makes a Venturi effect work. So Bernoulli's principle describes how the Venturi effect works, how it works. The Venturi effect is how we get something like an ejector to work. So Venturi is an effect, Bernoulli's is a principle. Remember those things, you should be good.